the class notes from today, 131. And you're probably going to have to pause this as we go because I didn't want you to have to wait and watch me write. So we started with solving by roots, which is the same as isolating x. And we wrote down our first example, which is x to the third minus 8. And we discussed how we were going to use SADMEP, which is the backwards version of PEMDAS. So the SA in SADMEP means you're subtracting or adding anything that is subtracted or added to the x. So we add 8 to both sides, and we get x to the power 3 equals 8. Now, this looks like something where you'd square root both sides, but to get rid of a cube, we're going to cube root both sides. So what that means is you draw a radical sign, but you put a little 3 here and a little 3 here. And so when you cube root both sides, this 3 cancels each other out. And you're looking for the third root of 8. And that is, what is a number that when multiplied times itself 3 times can equal 8? And that number is 2, because 2 times 2 times 2 is 8. Now somebody asked me, what about the plus minus? And you're not going to use the plus minus with third roots, because cube roots or third roots, they only have one answer. Okay, negative 2 times negative 2 times negative 2 is not the correct answer, because if I did negative 2 times negative 2 times negative 2, I'd get negative 8. And that's not the answer that I want. Okay, and now it just happens that I wrote an example that uses a negative. So we start off with x plus 1,000 equals 0. We're using reverse PEMDAS, so we're going to subtract that 1,000 from both sides. And then that's going to give us x to the power 3 equals negative 1,000. Now remember, we're going to put that little cube root sign on both sides. So it's a radical with a little 3, not quite the same as a square root. And then this 3 and this 3 cancel. And I have the third root here of negative 1,000. Notice the negative is inside the radical. It's part of the radicand. And what we're going to know is that a negative third root or a negative cube root has a negative answer. So the negative cube root of 1,000 is negative 10. Why is that? Because negative 10 times negative 10 times negative 10 equals negative 1,000. Okay, if you plug negative 10 back in here, you'd get negative 10 times negative 10 times negative 10. That's negative 1,000 plus 1,000 equals 0. We got it. Okay, we did another example. And again, the goal here is that we're solving by taking square roots. So if you were like, hey, couldn't I use difference of cubes here? Yes, you could. You'd get the same answer. But I was requesting that we do it using this method, the root method. Okay, and that means you're going to use a root at the end. The other way we learned to do roots, and we learned these first semester, was with square roots. So here you see x squared minus 49. And you might think, hey, couldn't I use difference of squares? Absolutely. Except for that the instructions we're using right now are solved by roots. And that means when you get to the end of the problem, you're going to want to isolate x and use a root sign. So what happens here is, again, we're using reverse PEMDAS. So we add the 49 to both sides. We're using inverse operations. I get x squared equals 49. I'm going to square root both sides. We've done this before. And remember, if you square root a variable, you have to put a plus minus on the other side. And so then if x squared equals the plus and minus root of 49, then x equals plus and minus 7. Okay, and I was telling everybody, it's okay if you write it like this now. You could also write it like x equals negative 7 and x equals positive 7. Okay, either one of those ways this way or this way is fine with me. Okay, and then there was one more example from this. And on this fourth example, I had to tell the class, like, no, that's not a typo. I wanted you to put x squared minus 44 equals 0. Add 44 to both sides. And you get x squared equals 44. Square root both sides using that plus and minus. And you might be thinking, well, there is no perfect square root of squared there. There is no perfect root of 44. You're right. But we learned how to simplify square roots. So how about square root 4 times square root 11, still with the plus minus? And that gave me a final answer of plus and minus 2 root 11. So that was half the lesson. And then after that, we did 13 through 17. We had a little bit of time to work on the end of that previous assignment. It was the day 4 assignment. And I've posted, or I will post in a few minutes, an entire answer key with all the answers worked out to that 3.2 day 4 homework. So you'll be able to check your work there. Then we looked at one more thing. Now, already in the video that we looked at when I was absent last Friday, you got to see about factoring out a greatest common factor. So the last page of that, number 7 and number 8, I showed factoring out a greatest common factor, and I showed factoring out a greatest common factor, and then factoring by another method. And so the next thing we did in class was we practiced factoring out a GCF, and then moving forward if there was anything else to do. So I created this graphic organizer, and you can, if you have a printer, you can download this and print it out. Otherwise, I will give you one when you get back. So I created this graphic organizer that's going to help us do these problems. So let's look at this one. X squared, that 1000x to the power of 4 plus 40x. So if we look at this graphic organizer, the first thing it asks is there a GCF? And between 1000x to the power of 4 and 40x, there definitely is. So if there is a GCF, you have to factor it out before you even begin to do anything else. So if we were really on our game, we would say, hey, there's a greatest common factor of 40x. You know how I always say, look at the smallest number? 40x is the GCF, because 1000 divided by 40 is 25, and both terms have an x. So if we factored that out, we would have found the greatest common factor. And so then the next thing you would do is you would say how many terms, and that means how many terms are inside the parentheses. So 25x to the power of 3 plus 1, that's 2 terms inside the parentheses. And then we ask ourselves, could this be a sum of cubes, a difference of cubes, or a difference of squares? 25x to the power of 1, it looks a little bit like sum of cubes, except 25 is not a perfect cube. So that means we're done. The only factoring to do here was to take out a greatest common factor. That's it. Because 25 is not a perfect cube, so we're done. Now, another thing about this problem is, more realistically, I realize that most people wouldn't know that 40 is a factor of 1000. And so in one of the classes today, they suggested that we factor out 10x first. And so when we factored out a 10x from here, we got 100x to the power of 3 plus 4. And then we realized, hey, we have to keep going because 104 have a GCF of 4. So now I've already factored out a 10x, but I also now have to factor out a 4. And that gives me 25x to the power of 3 plus 1. And I put the 4 outside by the 10. And now I have 40x, because I multiplied those. 25x to the power of 3 plus 1. And I stop here because there's nothing else I can do with that. It has two terms. I'm going to look here. It could be sum of cubes, except it's not cube. It's not 25 isn't a cube. So that means I can't factor it any further, and I'm done. Okay? We did another one. And on this one, we started with this 32x to the power 3 minus 50x. And the first thing you ask yourself is there a greatest common factor? And on 32x cubed and 50x, well, we know already there is one. There's an x. And 32 and 50 both divide by 2. So I could take the GCF out of 2x. 32 divided by 2 is 16. Take out an x, so that becomes x squared. 50 divided by 2, 25. And now I can see here how many terms? 2 terms inside the parentheses. And I can see that 16x squared minus 25 most closely fits the pattern of difference of squares. And since 16 and 25 are both perfect squares, I can break this down into 4x minus 5 and 4x plus 5. Bring down my 2x. And I'm done. Okay, because the instructions on these just said to factor it. There's no equal 0. Okay, that's literally all the notes that we took in class today. There was nothing that was actually new except for maybe taking a third root. Okay, and like I said, I will post all these notes. I will post this graphic organizer, and I made a complete answer key to the day 4 homework, and I'm about to post that in about 5 minutes. Hope this was helpful. Better record.